Great to talk to you again. This is your fourth part of your calculator, and we're going to learn today how to calculate the price of an ongoing bond. Now, this is very important because in this model, we're going to see reports, how to report a bond, which is another way of selling and borrowing and buying bonds in the market, okay? So if you remember your first part of the calculator where we did the fixed bonds, we used a bond that had a price of 86.8005. I'm going to use the same bond in here. So this part is the same information we used for that bond. We had a $100 face value, yield rate of 2.5, coupon rate of 1. It was a 10-year bond and its coupon period, it's every semester. This is why I put number 2 here, okay? Now, I'm going to start highlighting the cells that have calculations or formulas on it, okay? Number of coupons. Number of coupons is just a multiplication of coupons per year and years. Pretty simple, okay? Interest period rate, it's going to be your yield rate over the coupon period per year, okay? So the 2.5 over 2. Coupon amount is your face value multiplied by your coupon rate over the coupon period. So this is how much money you receive every semester per bond, okay? Now this part you already have it in part 1 in fixed bonds, which is the calculation of the present value of the coupons, a notional or nominal, and the bond price in here, okay? Same price that we used last time. Now, what happens when the bond walks in time or advances in time? Well, the price changes, okay? Because now the investment is walking or going on in time, so you don't have the same interests. This is what we're going to calculate today. In here, I'm going to add 2 cells, ongoing days and days for next coupon. And days for next coupon, I'm going to call them as DC, okay? Pretend that this bond has walked 150 days. So if you go back to your information, this bond pays coupons every 180 days. And we're assuming for this example that the bond walked 150. Therefore, your days for the next coupon is just the difference between 180 and 150. How did I calculate this? I just use 360, which is the year, over 2, which is a coupon per year, coupon period. That gives me 180 minus 150. Those are the days I have for the next coupon payment, okay? Now here's where it gets interesting. Because the bond has moved, I have different present values now. I'm going to build up the present value of the notional first because it's easier and it will lead us to understand how to calculate the present value of the other coupons, okay? So pay attention. I put this formula, present value of notional, over here, and I want you to follow it. Face value, first of all, we're going to get the present value of the face value, which is paid at the end of the bond. Present value 1 period before the bond began. So if you remember, this bond, this specific bonds has 20 coupons, right? Which means that the present value, the first present value we have to calculate is 19 periods before. So I'm missing a 9 here, okay? All right, so how does this work? We're just gonna use the face value, B2, present value, 1 plus my interest rate, this is the yield rate, over time. Time is my coupon period per year, okay? So I already have it divided here. Over over 19 periods instead of 20. Okay, I'm gonna lead this class with a video explanation of the graphs of this formula so you understand it better. Okay, but for now, just remember that we're calculating one period less than the entire periods of the bond. So we have 20 periods. We're getting the present value here of 19 periods. Okay, so what do we do with the remaining days? Well, we calculate also the present value of that. Okay, that is this part, which is this part underneath. 1 plus my interest rate over 360 times the days of the coupon. So if you think about it, you're calculating the present value up to period 1, okay? And then present value from period 1 30 days before. Right? Now, the present value of coupons, it's more interesting. As I said, we're only going to consider 19 coupons first. And that is this part of the formula. Coupons, the C will stand for coupon value, so coupons are 19. And we use the same formula for present value of a series of payments. Coupon value, which in this case is 0.50, or coupon amount, is the same. 1 minus 1 plus the interest rate. I use yield rate here. Okay, remember, I don't use coupon rate anymore. The only time I use coupon rate is to get the coupon amount. So I use yield rate here over T, which is over 2, which I over T is the same thing as interest period rate, okay? Same thing. Minus N minus 1. So this is 19, okay? And if you go back here, here, you have that part here, minus 19. Okay? Got it? Now, we're going to add one coupon amount. Why? Because in the first period it also pays one coupon. Okay? We're still receiving 20 coupons. And in this part of the formula, we only calculated it for 19 coupons. So we're missing one. And this is why here I add an extra coupon. Okay? Now, final step, I just take this amount back 30 days. 1 plus interest rate over 360 times days of coupon. Okay? That is this part. And the current price, I'm just going to add these two. Okay? Now you would say, or you would think, why is it higher? The price is higher than the 86.8005. Well, that's because you're closer. If you advance 150 days, you're way closer to get the coupon payment. So whoever wants to buy this bond has to pay extra money, or a little bit money than the person that bought it 150 days before. This person here that bought it on the initial day had to wait 180 days to get the first coupon, as opposed to this person here that only has to wait 30 days to get the first coupon. So that's why the price is a little bit higher. Okay? So work on your calculators, okay? And later this week I'm gonna upload a video explaining with graphs what are we doing here. This is the first step to understand reports and buying and selling and profits in bonds, okay? Nice to talk to you guys. Take care.